All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel, leave a like, comment, and share. Now, in today's lesson, I am going through this assignment from the African Institute for Mathematical Science. Actually, this is an actuarial mathematics course, and basically the assignment is trying to build your foundation in understanding the annuity and the future value of money. So unfortunately, I'm not going to do all the questions in this assignment. And my basic question of interest is question 4. So we'll do question 4 together. Then we'll see if there'll be enough time we can look at the other questions. Yeah, so but let's go on. Don't forget to subscribe. Now, question 4 reads, a bank offers a savings account for which interest is compounded at an effective interest rate that depends on the actual value AT of the savings account as follows. So the actual value AT is the money that you put into the account. And this money that you put into the account, if it is below $7,000, okay, it has an interest of 5%. But if this money that you put into the account is above $7,000, then it will grow at a rate of 7%. So that's the basic reading. If the money that you put it into the account is between $0 and $7,000, okay, $7,000 not included, the money will grow at a rate of 5%. And if it is above $7,000 or $7,000, then the money grows at a rate of 7%. Okay? T represents the number of years. An investor invests $1,000. Okay? So since this $1,000 that he invests is below $7,000, we know that the $1,000 that he invests will have an interest of 5%. Okay, so an investor invests $1,000 into the account at time 0. He also invests $500. So again, the $500 is below $7,000. So meaning that this $500 will grow at an interest of 5%. Okay, but what he does is he invests this $500 every year for the next 15 years. Okay, and the question is, since he is investing this $500 every year plus this $1,000 that is just sitting into the account once it has been invested, at what time is he going to have $7,000? Okay, so now remember, when he has $7,000 invested into the account, the interest rate changes to 7%. Okay, so now what is the question saying? From what time will the investor receive an interest rate of 7% per year? Okay, so we know that the interest rate changes from 5% to 7% if and only if the investor invests $7,000. Okay, so now I'm going to put a timeline here so that we have a better intuition of the question. Then I'll say at time 0, the investor invests $1,000. Okay, so we know that by itself at time 0, when he invests $1,000, though it might take long, at a rate of 5%, this money may grow by itself to be $7,000. Then when it becomes $7,000 by itself, okay, we don't know at what time, then it can change to a rate of 7%. Okay, but that is not what is happening. So what we'll do is we'll hold on to this $1,000 that he has put into the account, and consider that this gentleman at time one, he puts in $500. So this $500 begins growing interest while the $1,000 is also growing interest. In the following year, he puts in $500, which is also growing interest independently. At year three, he puts in another $500, which is growing interest independently. Then he does this and so on and so forth until year 15. And at year 15, he also puts in $500. All right. So now the task is we want to find the time at which the money he will put in will be $7,000. And we know that at this time, the interest onwards will start being 7%. Okay. So this $1,000 at this time t plus the accumulation of all these, let me use it color, let me use the same color, all these accumulated up to that time, okay, then we are going to have change in the interest. This $1,000 by itself up to that time, these monies up to that time, when they get to $7,000, we are going to have an interest of 7%. And what we're interested in is what is this time? Okay? What is this time? So basically, the idea is we know that at $7,000, we will have change of interest from 5% to 7%. Now, this will only happen if we accumulate enough, considering the accumulation of the $1,000 plus the accumulation of the $500. Okay. Now this $500, remember, is accumulating geometrically. Okay, so this will accumulate maybe t times, this will accumulate t minus 1 time, this will accumulate t minus 2 time, and so on and so forth. Okay, so this one is accumulating geometrically. Okay, so now for the first one, that is only accumulating once up to this time t. Finding the value there is just the future value. So the future value at time t will be equals to the present value, which is $1,000, times 1 plus the interest to the power t. Okay, this is t, the time that we get there. So the future value at t is the present value plus 1 plus interest to the power t. Okay, so that is what we're looking for. So the present value we have, the present value is 1,000 plus 1 plus, we know that the 1,000 is growing at an interest of 5% because 1,000 is below 7,000. So this is going at the rate of 0.05. And what we're interested in is to find this t. So we'll put it here. So we'll say 7,000 will be equals to the future value of the 1,000, which is 1,000 times, okay, times 1 plus the interest rate, which is 0.05 to the power t, plus the accumulation of the $500 is geometric. So we can say this is 500, and we sum all the interests from 0 to n minus 1. This is 1 plus I to the power n. We know that this converges to 1 plus I the power n minus 1 over the interest. Okay, so we can simply write this. Let me rewrite it here. So it will be 7,000 is equals to, we can sum this, 1,000 open 1 plus, which is 1.05 to the power t, plus the 500, uh, 1 plus I the power t minus 1 over I. Okay, we know what I is. The 500 is growing at a 5% rate. So I can simply replace this with a 1.05. Even here we will replace with 1.05. Okay. Then now what we just remain with is solving for t. Okay. Oh, sorry, this is 0.05. So since it's the interest, 0.05. So this is the interest. Okay, so 0.05. So we can multiply throughout by 0.05. So we multiply throughout by 0.05. We'll get 350 here, 350. Here we'll get 50. Then we have 1.05. The power t. We distribute this. So 0.05 times this will cancel out. So just distribute this part. So this is plus 500. 1.05 to the power t minus 500. Okay, so we simplify everything. This and this can sum to 850 equal to, so this and this can sum to 550, 1.05 to the power t. So now you can divide throughout by 550, divide by 550. We see that the zeros can cancel out, and we have 85 over 55 equal to 1.05 to the power t. And what we can do is we can introduce natural log both sides to solve for t. So natural log both sides, and the t will drop. So basically we're going to have t natural log of 1.05 equal to natural log of 85 over 55. Okay, so you divide throughout by natural log of 1.05 over natural log of 1.05. Then you solve for t. When you simplify that, you find that t is approximately 9. Okay, so that is the time that we have. So 9 in years. So we see that this will not get to 15 at time equals to 9 years. We're going to reach $7,000, and this $7,000 will start accumulating at a rate of 7%. Right, so that is about this question. So if you have questions on this question, I can answer them in the comment box. So yeah, feel free to reach out. Have a great evening, great morning, great day. See you around.